Welcome back. A technician experimentally, there's a keyword, determines the boiling point of octane to be. So experimentally did a measurement. So there's our experimental value. And the actual or the true value or the accepted value of the boiling point of octane is 125.7. So the equation or the formula we need for percent error is going to be the absolute value of the experimental value, the measured value, minus the accepted value or the true value over the accepted value times 100 to turn that into a percent. Now you may say, well, what's the point of when does it matter this order? Not if you're getting the percent error because it's going to be the absolute value anyway. But here it does ask us for the error as well as the percent error. So this here component, this part, which I generally won't ask you on a test, but this textbook is asking you, so I'll go over that. This part is known as the error. I'm not pointing at that specific word, but this whole section. Okay, so let's answer the error. Error without absolute values is the experimental minus the accepted. That's all it is. So the error can be negative, is in other words. So we'll plug these numbers in. Experimental is 124.1 degrees Celsius minus the accepted is 125.7 degrees Celsius. Plug that into our calculators. 124.1 minus 125.7 is negative 1.6 degrees Celsius. So this error in that measurement is negative 1.6 degrees Celsius. So let's do the percent error. We have this error, we just calculated, and now we can get the absolute value of that. And we're going to put that over the accepted value, which again is 125.7 times 100. And that's going to give us our percent error. All right, so that number, which is it's just going to be 1.6. Once you make it positive, divided by 125.7 times 100 is going to give us 1. Well, no, after this, you know what? I should have backtracked a little bit. Okay, so just to be clear, this is proper sig figs because when you add or subtract, your calculated answer has to have the same number of placeholders as the measurement with the least precision, but they both have the same precision, which is to the tenths. So this part here is good. Now, since we're doing a combination of multiplication and division and addition and subtraction, we've got to follow the rules after each operation. So now in this case, right here, we're doing multiplication division. So now we got to follow sig fig rules. All right, so sig figs, 2 there, we got 4 there, we have unlimited there. All right, so our answer has to have, what do you think? 2 digits. All right, so get back to my green. 1.2728 and blah, blah, blah. All right, we got to keep that. We have to peek at the next one to see if we keep our 2. We're not. We need to round that up to 1.3 is going to be our final. And don't forget that percent sign. There's our answer, 1.3.